Concrete masonry units, or CMUs, are precast concrete blocks that are commonly used in construction. Around 4.6 billion of them were produced in 2014, which shows just how popular they are in the construction industry. They are used for a variety of applications, such as structural and for decoration. The history of them, and this is the history of them. Although the concrete masonry unit is a relatively recent invention, concrete blocks have been around for quite a while, and concrete itself has been around for even longer. The ancient Greeks and Egyptians used lime-based mortars and plasters in their construction. But the ancient Romans are regarded as the civilization to perfect the construction and use of concrete. The Romans were one of the first civilizations to use concrete as a widely used building material, with many aqueducts and important structures utilizing poured concrete or cement. One of the most notable of these is the Pantheon. As Hall J.P. put it in his thesis, the Pantheon may be the first grand structure that utilized concrete, or Puzolia, as it was called by the Romans. I don't know if I said that right. It was constructed in the 1st century A.D. The Pantheon is regarded as the largest unreinforced concrete dome in the world, and is also thought to be one of the oldest structures in continuous use. End quote. Many other structures that the Romans built using concrete are still standing to this day. After the Roman Empire, the expertise and knowledge needed for making and using concrete was lost. Concrete would not be used in wide-scale construction until more than a millennium later in 17th and 18th century England. In a rather controversial debate as to who created the first concrete block, there is some evidence that a primitive version of concrete was used to create blocks that were used to build the pyramids, though this theory is far from proven. Although the Romans used poured concrete in building applications, there is no known evidence that concrete was molded in block form. The big advancement that allowed concrete to be used in the 17th century was the invention of Portland cement, a key ingredient of concrete used to create the concrete blocks that were used to build. Now I lost my place. The big advancement that allowed concrete to be used in the 17th century was the invention of Portland cement, a key ingredient of concrete even today. It was created by an English stonemason named Joseph Aspdin in 1824. Less than 10 years later, in 1832, an Englishman named William Ranger took out a patent for solid concrete blocks. It is widely regarded that the first hollow concrete block was designed in 1890 by a man named Hartman S. Palmer, who lived in the United States. He experimented with the design for 10 years before taking a patent in 1900. Palmer's blocks were so heavy at the time that they had to be lifted by a small crane. And here's the production of them. The company Netter House is a concrete masonry unit manufacturer that has been making concrete blocks since 1923. As they put it, the process of making concrete masonry unit hasn't changed much since its inception in the early 1900s. Raw materials are mixed with water, formed into a mold, and left to cure for a period of time. The basic process is simple, but with advancements in the industry over the years, CMU manufacturing has become a science of chemical engineering and architectural integrity. Concrete masonry units have been around for quite some time, though machines have replaced what used to be done by hand. End quote up there. Not a lot has changed in CMU manufacturing. Seeing how it's done now offers a glimpse into the early 1900s. The first step in making concrete masonry units is to gather raw ingredients. Standard concrete blocks require Portland cement, water, sand, and gravel. The sand, gravel, and water are naturally acquired resources. The sand and gravel are both acquired from mines and have to be shipped to the CMU factories, while the water comes from standard water treatment plants. The Portland cement has to be manufactured. It's made by burning a mixture of pulverized materials containing lime, silica, and alumina. The results formed from this burning mixture is a product called clinker, and this clinker is then crushed into a fine powdery mixture called Portland cement. Portland cement, like most types of cements, is sensitive to water, so it's typically stored in moisture-controlled silos, while the sand, gravel, and any other aggregates are stored in open air storage, such as outside or in an open warehouse. It is worth mentioning that there are other types of materials used for concrete masonry units. designs, and even standard CMUs can have materials added to modify their properties. The concrete mixture that is used for blocks has a higher amount of sand and a lower amount of water and gravel than concrete mixtures used for general purpose concrete. Many people use the word cinder block to refer to every concrete masonry unit, which is a misconception. Cinder blocks are a type of concrete masonry unit that uses granulated coal or volcanic cinders instead of sand and gravel, which makes the block dark gray. Lightweight concrete masonry units are made by replacing the sand and gravel with expanded clay, shale, and slate. Expanded clay, shale, and slate are made by taking regular clay, shale, and slate and heating them up to 2,000 degrees Fahrenheit. These lightweight concrete blocks are used to make non-load-bearing walls. Lightweight blocks can also be made with expanding blast furnace slag and natural volcanic materials. Any of these concrete masonry units can contain admixtures as well as their core ingredients. The admixtures can alter curing time, increase compressive strength, or improve workability. Pigments may also be added to change the color of the blocks, and bake-on glaze can be used to give the blocks a decorative effect. After the ingredients are acquired, they need to be mixed. The sand, gravel, and Portland cement, or whatever aggregates that are used in place of sand and gravel, are electronically weighed for accuracy and mixed together in large industrial mixers. Water is then added into the mixture along with the admixtures. The amount of water is monitored with an ultrasonic device to make sure the ratio is correct. The mixture is then taken out of the mixer and placed into molds. When the molds are full, pressure is applied to them to compact the mixture. Mechanical vibration is usually used to compact the mixture further, and the now compact blocks are then taken out of the molds and placed in a curing kiln. There are two basic types of kilns: high-pressure steam kilns and low-pressure steam kilns. Low-pressure steam kilns take longer to cure the blocks, usually 24 hours, are cheaper to buy, and use less energy. High-pressure steam kilns take less time to cure the blocks, but they're more expensive and they require more energy to use. After the blocks have been cured, they are then ready to use in construction. Concrete masonry units are commonly used in the construction of walls and partitions. They are common in commercial and industrial construction and are sometimes used in residential. They can be used for load-bearing and non-load-bearing walls and can be used both inside and outside. The first step in building concrete masonry unit walls is to place the foundation. When it comes to freestanding foundations, or foundations that exist for the sole purpose of supporting a CMU wall, it is typical that the foundation be twice as wide as the wall itself. The depth of the foundation depends on the expected load of the wall and the building codes in the area it's being installed. Wall reinforcements such as vertical rebar need to be placed when the foundation is being poured. When selecting the blocks to use, there are a few things to keep in mind. The size and shape of the blocks, depending on the load of the walls, as well as how the wall is meant to look. The most common size for concrete masonry is 8 by 8 by 16 inches. Keep in mind that this is the nominal size of concrete blocks. The actual size of concrete blocks has roughly 3/8 inches taken off of each of the dimensions. This is to compensate for the thickness of the mortar joints that will be applied. In most cases, not all the blocks needed for a wall will be the same size. Sometimes half the blocks are needed for the sides and corners. Blocks sometimes need to be cut to accommodate odd dimensions, and the wall blocks sometimes need to be cut to accommodate odd dimensions on the wall, or objects such as wires, switches, and reinforcements need to be installed. The mortar is usually prepared on site and is applied to each joint in the blocks. Reinforcement has to be installed as the wall is built upward. The mortar then needs to be smoothed and the wall needs to be filled with concrete if necessary. There are different types of walls that can be built with concrete masonry units. One common one is load-bearing walls. These walls carry the weight of the roof or floor above them. They can be thicker, sometimes using thicker blocks or making the walls 2 blocks wide. They usually have more rebar running through them as well as other support that is often poured solid. Another type of wall is the veneer wall. Veneer walls are not load-bearing and are usually only designed to resist wind loads from the side. Even then, they usually rely on another structure to transfer the wind load to. Veneer walls are also designed as drainage walls. A cavity is usually placed behind the veneer wall to allow the wall that gets through it to drain water that gets through it to drain down. Flashings are often installed in them to allow the water to drain into the exterior of the building. Another wall type that is commonly used for outside walls are hollow walls. Hollow walls do not have concrete poured into them, or at least have less concrete poured. This increases the thermal insulation of the building and helps with climate control. Some of the pros and cons of CMU blocks. Before the pros and cons of concrete masonry units are weighed, they need to be compared against some alternatives. It does not make sense to use concrete masonry units for every wall that needs to be built. If a wall is not an outside wall, a load-bearing wall, or a wall that needs some resistance, then it does not have to be made out of concrete masonry units. Sheetrock walls that are supported by wood or steel make good inside partitions that are cheaper and easier to construct than concrete masonry partitions. Since concrete masonry walls and non-load-bearing sheetrock-based walls are used in different applications, it is not that balanced to compare them to each other. One wall type that is in direct competition with concrete masonry walls is insulated concrete form walls, or ICFs. How insulated concrete form walls work is by taking these foam units, such as in the picture above, which is basically two foam plates that are separated by a distance using steel reinforcement, and thus creates a sort of a trench pattern that can be stacked on top of each other. They stacked on top of each other, and then they are poured with concrete. The result is a concrete wall that is surrounded by foam insulation. In terms of performance, insulated concrete forms beat the concrete masonry wall units hands down. ICFs are much stronger than CMUs, even with rebar reinforcing. Concrete masonry unit walls are not as strong as insulated as concrete form walls. In terms of speed, ICF walls take less time to construct than CMU walls. Not only do insulated concrete form walls take half the time to build as concrete masonry unit walls, but they can be built with half the crew. They're also far lighter and easier to handle than concrete masonry walls, making them safer and less liable to cause accidents on the job site. They are easier on other trades as well. I can speak from experience that it is difficult to install communication lines and other devices in concrete masonry walls, especially ones that have already been poured. It is easier to install things in ICF walls, especially drywall, as the anchors that are required to install drywall in CMU walls are not required in ICF walls. In terms of cost, it is less clear which option is cheaper. On the surface, it would be tempting to say the CMU walls are cheaper because contractors that handle CMUs usually bid less than the ones that bid ICFs. But CMU contractors do not include the price of rebar reinforcement in their bidding. That is usually handled by another company. Things such as waterproofing of CMU walls are also not covered in the bidding. ICF walls are also better insulated than CMU walls, which cuts down on power usage in the long run. So all in all, it seems CMUs are still outmatched by ICFs.